Hi, it's Sam. In this video, we're going to start looking at some advanced MIDI sequencing topics, starting with keeping time. We're first going to talk about relative timing, which is trying to answer the question, how much time has passed since we started the sequencer? So this is not tied to the transport or the timeline position. This is going to be just based on after we started the transport or the sequencer, how long has it been? And this can be tied to when the transport starts or stops, but it doesn't have to be. So let's take a look first at how to set up the transport. So in Max, you can just use the transport object to start and stop the transport. When you're in Ableton using Max for Live, you can just use plug sync to report if the transport is on or off. And you should use the change object with -1. Why? Because plug sync will always be sending out a 0 or a 1 based on the current state of the transport, and you don't want to flood your code with these 0s or 1s. You just want it to send one time when it changes. And by default, change has an internal argument of 0 if it has no argument. So if you were to start your code and the transport is off, it'll send out a 0 and then it won't go through change because change internally has a 0, so it will think that the value hasn't changed. Now, -1 is not an option for plug sync to output for the transport state, so that is a safe argument to give it so that it will ensure that when it's initialized, it will always send through the 0 or 1. So let's just set up the kind of max version of this code. We're just going to add transport here, and I'll just add a message box so we can see the current state of the transport. And you can see the transport's actually on right now, so let's turn it off in the bottom right here. And I could turn the toggle on to start the transport, and then toggle it off to stop it. And you can see in the very bottom right is when it's on and off. When it's on, you'll see a little pause symbol, and when it's off, you'll see the play symbol. Now we can use Metro and Counter to set up relative timing. Now you can't use tempo relative values like ticks and note values, bar beats and units, unless the transport is running. So that means that if you want a sequencer that runs when the transport is stopped, that you have to use something else, like milliseconds is what I typically use, and that's the example I'm going to use. But let's start off by setting up sequencer timing that uses the transport. So we're going to use some tempo relative intervals just of eighth notes for this example. So let's set up a metro with the argument 8n, and we're going to use two different attributes, quantize with an argument of 8n and active with an argument of 1. And we're going to send the bangs that come out of the metro to a counter. And I'm just going to add a message box so we can see the current count. So let's go over what these arguments mean. 8n is the interval, so that's going to be eighth notes. Quantize is the quantization amount, so this is being quantized to eighth notes. And active 1 means that by default the metro is active. But because this is a tempo relative value, it'll only send out bangs when the transport is on. But when the transport is on, it'll automatically start to send out bangs. Now, visual kind of helps understand how quantize works. So when quantize is off, it'll still output the timing correctly of eighth notes, but they might not be lined up with the beat of the transport. So the eighth notes that are in the timeline, those exact divisions, it might be offset. But again, they'll still be spaced equally as eighth notes. So what this does is it lines them up with the timeline position of those eighth note divisions. And I usually set the quantize value to whatever the interval value is. So let's expand this to include some other logic, but first I'll just show you how this works. So I turn it on and it starts counting. I turn it off, it's going to stop the count. Then I turn it back on and it will continue from where it stopped. So let's add a little more capabilities though. Specifically, I want to add logic that will reset the count when the transport restarts, and also something to reset the count immediately. And so the middle inlet of counter, it resets the counter to whatever number you send that on the next clock. So we're going to use that to set up this logic. So let's add it first. We already have the transport on off here, and we're going to use root pass to send messages based on if we're turning the transport on or off. So when we're turning the transport off, we can just pass that 0 through. When we're turning it on, we're going to have to check if we want to reset the count or not. So first, we're going to check if we're resetting the count. If the value is 0 that's being stored in this integer box, then we will want to reset it. Otherwise, we're not going to do anything. So let's create another toggle that'll be our reset the count toggle. So when that's on, that means that we want to reset the count when the transport stops. And we're going to use equals 0 because we want this value to be 0 when we want to reset the counter, so that 0 will be stored here and go out to counter, because we need that 0 to reset the counter to 0. So we're going to use root pass 0 to let 0 through if that is the current value in the integer object. Otherwise, it'll just be ignored and nothing will come out. And it's easy to set up the reset count on next bang. We just send a 0 to the middle inlet of counter. Then finally, we just need to make sure that after we check if we should reset the counter, then we can turn transport back on. So let's give this a try. So just like before, we can turn it on and off, just start and pause the counter. So it's going, and now I can pause it, start it again. And then I can also just reset the counter at any time by just hitting 0, and it'll reset that. Now if I turn this on and off, it won't interfere with the counter because it's only going to be checked when we turn the transport back on. So let me turn this off. And then I can, I can do this as many times as I want, but it won't be checked until this moment. So I didn't turn it on, so now it did not reset the counter. But if I turn it on and then turn the transport back on, now it's resetting it. So depending on the behavior that you want for your sequencer, this can be useful. It can be an optional addition, or it can be permanently on. Now let's build something that runs independently of the transport. And for this, we're going to use milliseconds because, like I said before, tempo relative values like note values, Metro will not output those if the transport is not running. So like before, we're going to use a toggle, but now instead of attaching that to transport, that's going to go directly to the Metro to turn it on and off. And we can still use our note values. So we still can use 8n, but we're going to have to translate that or convert it using the translate object from note values to milliseconds. And that'll go into the right inlet of Metro. And then like before, we can just set up our counter and view the count. So now if I send in this message, we have 300 milliseconds is an eighth note. Let me turn this on, and now it's running. And of course, we could integrate the same logic we used before, except for now instead of the transport, we're just going directly into Metro. Another approach that may be of interest to you is using the MIDI keyboard to start and stop a sequence. So what we can do for that, let's set up a K slider. I want to put it in the attributes. I'm going to change the display mode to polyphonic. And we're going to send this to Borax. And there's this particular function of Borax that'll be useful for this. So first, let's just hook it up. We send the pitch to the leftmost inlet and then the velocity to the middle inlet. And if you look at the third outlet, it tells you the number of notes that are currently active. So the logic is just going to be using greater than 0. So all this is asking is there a note that is active, yes or no? If there is, then we're going to get a 1, which will turn on Metro. Otherwise, we'll get a 0, and Metro will stop. So we can just put this directly here. And now when I start, see I've got like a few notes down, I can just release them all. Now it's inactive. And it'll start again. So that can be nice if you want to allow the MIDI keyboard to start the sequence. Now, if you wanted to set this up to work with our previous example, you'd have to change active 1 to active 0, which I believe is the default anyways. Let me double check that though. Yeah, it's not active by default. So now if I turn the transport on, Metro is not running. So what you could do is plug this into Metro, and now you can have it running. But of course, if the transport is off, it's not going to run because that doesn't work for the tempo relative values. But in this way, at least you could still use the MIDI input to drive the counter here. Now let's move on to absolute timing using ticks. So ticks are independent of the tempo and time signature. So for example, a quarter note is always 480 ticks, no matter if the tempo is fast or slow, 4/4 or 6/8 time signature. And the raw ticks, which we're going to be using in this example, give you the absolute time, the actual transport position. So for example, if one quarter note has passed in the timeline, the position is going to be 480 ticks. That's going to be the same position no matter what. So let's build the start of this logic. We're going to be using Metro here, and we're going to set it to 32N, so 30-second notes. And again, we're going to use quantize and active 1. And we're going to still send this to transport. And out of the second to last outlet, we will get the raw ticks. If you're in Max for Live, you can also use plug sync's third to last outlet. However, that uses 1 tick to equal 1 quarter note. So if you want to convert that to the raw ticks, you'll have to multiply it by 480 and make sure that you use a period so you get floating point math. Now for the Metro here, you want to use whatever the fastest rate's going to be for your sequencer, because sending a bang into transport makes it report the current value, whatever values it's sending out here. And so if it's not going fast enough, you're not going to get the current tick position quickly enough, and it's not going to be accurate. So make sure you set this to whatever your fastest interval is going to be that you're using for your sequencer. So let's add a toggle so we can turn the transport on and off, and also add a message box with a 0. I should make it a floating point on the far, or not on the far, just on the right inlet, so that we can kind of rewind it back to the beginning. So now we're going to change or convert this value, these raw ticks, into a 0-based absolute step. So by zero based, I mean that the steps are going to start from zero. So we'll go 0, 1, 2, 3, etc. So to do this, we're going to take the raw ticks and divide it by the rate in ticks. But we also need to convert that to an integer. And an easy way to do this is just use the expr object so that we can just put everything into one expression. So let's set this up now. So we're going to take, first we're going to make sure that we convert all of it to an integer. That's just this like int function. And we're taking the first floating point and dividing it by the second floating point. So in one side, we're going to get the raw ticks on the left. And then on the right, we're going to get the current note value in ticks. So we have to say translate note values to ticks. So let's make sure to initialize this. Then we can also add change again, because otherwise we're going to get a lot of values coming through because the transport is going to be sending out lots of numbers. So we only want it to output the current step when it's been changed. Okay, so let's see now the output. Okay, now we have these ascending steps based on the current position. So if we go back to 0, at the very beginning, it'll be 0 again. So to reiterate, the idea here is that these correspond to an exact position on the timeline. So if you're at the very beginning, it's always going to be 0. If you're somewhere else, it'll always be the same number. It doesn't matter where you go, it'll always be the same number for that position because we're using these raw ticks that represent the position in the timeline. Whereas before, we were just seeing how long has it been since we started the sequencer and just counting from there. So to get the index for the sequencer, we're going to take this step and use modulo math based on the length. So let's say that we have a 16-step sequence. So we're going to take the step and we're going to do mod 16, and now we're going to get a number between 0 and 15 because, again, this is 0 based. So let me restart this and go 0 up to 15, and then it will restart again. Now, if you want to make this 1 based, because it's a little more intuitive, maybe, then you can just add 1 at the end. So now it'll go from 1 to 16 and reset. Hope you found this tutorial useful. In the next tutorial, we're going to look at using phaser for our timing and how it's pretty easy to add swing when you're using phaser for your timing. So please let me know if you have any questions or comments. Otherwise, until next time, class is dismissed.